Rain by Candace Curtis. Students produce misconceptions as a result of their own interpretations from past experiences. It is up to us, the teachers, to identify these misconceptions and turn them into factual understandings. Teachers can use many techniques to identify these misconceptions, such as diagnostic tests, concept maps, interviews, or drawings. Majority of misconceptions fall under the category of physical science. Many deal with the properties of water, phase change, the water cycle, cloud formation, and precipitation. I've decided to focus my scientific experiment on the water cycle and what produces rain. With this experiment, I hope to gain knowledge to help with teaching the water cycle. Students come to school with different background knowledge and ideas, and not all of it is correct. Teachers must fill this gap and make sure all students are learning the correct information. When students are first introduced to the water cycle, they automatically think about what they already know, which is usually rain. Rain comes from clouds, but where do the clouds come from? With no prior instruction, most children think that God or people made clouds. Then they develop the thought that clouds are a form of smoke, and eventually they think that clouds are made of water, air, or heat. With this thought of clouds, they are lost when the question of where does rain come from is asked. Some more common misconceptions are rain comes from holes in the clouds, rain comes from clouds sweating, comes from when clouds get scrambled up and melt, or when the clouds are shaken. All these answers are obviously misconceptions. Most educated adults can tell you that the water cycle consists of evaporation, condensation, precipitation, and runoff. They can tell you this much, but do they really understand the process of each step? A drawing survey was given to college students, and the results showed that only 44% of the students had partial knowledge of the water cycle. Majority of these students were taught through lecture and traditional teaching strategies. This shows how important hands-on experiences is for students. To fully understand the water cycle and mechanisms for rain, students need to understand the process of evaporation and condensation. To help students understand the water cycle, I will have them do an experimental investigation. In this experiment, I will explain the steps of the water cycle and what each process is. I will ask the research question, what causes rain to occur? And does the depth of water affect rainfall? I will then create a hypothesis. Rain occurs because hot air holds moisture. When the hot air rises and meets the clouds, it causes the clouds to fill with water. Then the water falls from the clouds because of gravity. I don't think that the depth of water affects rainfall. I will have a glass jar, bowl, and a cup. All will be clear so I can see the rain when it falls. I will also have a plate placed on top of each container, and it will be filled with ice. Each container will have 1 cup of water in it. Since the amount of water will be the same, but the depth will be different, this will be the independent variable. This will determine the amount of raindrops that fall, which is the dependent variable. The water temperature will be the same in each container, which is the controlled variable. I will test each amount of water 3 times and time which container produces raindrops first. This will determine if water depth affects rainfall. I will watch each container and count the raindrops that fall within 1 minute after the first raindrop falls. I will collect data of what happens with each test. Then I will look at the depth of the water and determine which provided the most rain. If they all produce rain at the same time and the same amount of rain, then I will know that the depth does not affect the water cycle. This experiment will also allow students to physically see each step of the water cycle and decide what factors cause it to occur. The steam represents evaporation. The collection of water on the bottom of the plate represents condensation, and the falling drops represent precipitation. This is not lecture-based, so hopefully the students will learn the process and remember what causes each of them. For my experiment, I boiled 3 cups of water. I divided the water up and put 1 cup into each of my containers. I then put a plate on top of each container and filled it with ice. I started my timer and waited and watched. The smallest cup, which had the deeper water, produced rain first at 2 minutes and 18 seconds. It produced another raindrop about 30 seconds later and another about 55 seconds later. The next one to produce rain was the jar, which is the second deepest. Its first raindrop fell at 3 minutes and 2 seconds. It produced another raindrop at the same time the bowl did at 3 minutes and 47 seconds. I did this experiment 2 more times and got similar results. My first set of results represent the time it took for the first raindrop to fall in each container. By looking at the bar graph, it's obvious that the cup, which had the deepest water, produced rain at the fastest rate. The jar had the second fastest production of rain, and the bowl had the slowest production of rain. This shows that my hypothesis was wrong. I stated the water depth would not affect the rain, and it did. My second set of results show the amount of raindrops produced in 1 minute after the first raindrop fell. My experiment showed that the cup produces the most amount of rain within 1 minute. In all 3 trials, it produced 2 raindrops in less than 1 minute. The jar produced the second most and the bowl produced the least. I have included the time in which each drop fell on the bars. I did not encounter any difficulties carrying out this experiment, and I think it could be easily done in a classroom as long as there is a heating source for the water. If I am to do this experiment in the future, I would like to experiment with the water temperatures that I placed in the container. So my research question would be, does the water temperature affect evaporation? Student concepts will be based off of their prior knowledge of rain and what we learned in class. This will help them understand what happens to water if it's left out and where it goes. It will also help them understand the effects of a drought. After doing this experiment in the classroom, students should be involved in a science inquiry. They will be prompted to ask questions, gather data, and form theories. This experiment also demonstrates the nature of science. We, the scientists, created the science experiment. So, it proves that science is something that people do and create to find out information about a particular topic by investigating, observing, and explaining. Thank y'all for viewing my presentation, and I hope you enjoyed it.